In the world today, we find batteries wherever we look. They range from small button batteries that power watches or some remote controls, to larger batteries that power flashlights or toys, to gigantic electric vehicle battery arrays or industrial storage centers. Other than space considerations, why do we have so many different battery sizes and power specifications? How is our current use and desire for portability and increased power capacity shaping the design of batteries?
What is a battery? First, we should explore what is a battery. The purpose of this video is not to explain all the ways that batteries are configured and work, but to explore the different sizes and uses of batteries. However, it is useful to know the way a battery operates. The dictionary definition is a container consisting of one or more cells, in which chemical energy is converted into electricity and used as a source of power. Generally, in a battery there is flow of electrons from the anode, the negative terminal, to the cathode, the positive terminal, through an external circuit which creates an electric current which powers a device. The external circuit complexity ranges from a wire connection to a series of electronic components that does some work, such as producing light or mechanical activity. When a battery is connected to an electronic device and the circuit is complete, it discharges, and the chemical reactions cause electrons to flow. This powers the device. Recharging involves reversing the chemical reactions by applying an external electrical current. Why are there so many types of batteries? We have so many sizes of batteries since for many devices we want the device to be portable and easy to carry. Examples are watches, laptops, cell phones, flashlights, and toys. Obviously, we don't want to haul around a cell phone with a 1-pound battery. The trade-off for the small size is less storage capacity. This lower storage capacity for the batteries in cell phones, tablets, and laptops results in having to recharge them frequently. There has been considerable work in recent years to increase the power of the batteries of these devices. This purpose is to increase the duration the battery will operate before recharging is necessary. For some small devices such as watches and remote controls, the power required is so small that batteries can often last a year or more before the batteries need to be replaced or recharged. However, even for the small devices, there is often a wide variety of batteries that are needed for different devices. There are many different button cells or small batteries that can be used to power these devices. Sometimes there is a difference in voltage requirements, such as either 1.5 volts or 3 volts. If a device requires 3 volts to operate, it can use either a 3-volt battery or to 1.5-volt batteries in series. Which one is used is determined by the design and manufacturing process for the device and will be reflected in the size of the battery compartment and location of the connections. Button cells usually range from 2 to 5.4 millimeters in thickness and 6.8 to 24.5 millimeters in diameter. They usually provide 1.5 volts of power, but 1.4 volt, 1.55 volt, and 3 volt button cells are also common. As with other batteries, the size and voltage are determined by design constraints and design choices. Although both C-size and D-size batteries are still widely used, there are currently fewer devices using them than in the past. Also, 6V batteries that commonly power large waterproof flashlights are still used. They are not as common as they used to be since the introduction of brighter LED bulbs. Batteries are also used in a UPS or uninterruptible power supply. They usually function for a short time in the case of a power outage. They are often used to support critical functions, such as to keep computers or servers online. They are also used in hospitals to keep crucial equipment functioning in the event of a power failure. Combustion engine vehicles usually use 12V batteries that are primarily the energy source for starting the engine and for supplying electricity to the electronic components, such as radios, lights, and automatic windows. Electric vehicles use batteries with voltages ranging from 400 to 800 volts. In recent years, we've also seen the introduction of large household batteries to store solar power. They can be used for electricity within a household or to charge electric vehicles. The price of these batteries varies widely depending on the storage capacity. They generally run from $2,500 to over $20,000. They can store power that ranges between 5 kilowatt hours to over 50 kilowatt hours. Depending on the battery and import source, they will take between a few hours to over 12 hours to completely charge. Batteries connected to an array of solar panels usually take between 8 to 10 hours of direct sunlight to completely charge. Finally, we have large batteries that are used to store electricity used for industrial operations. The storage capacity of industrial batteries varies widely and is used in a whole range of industries. The storage capacity can be a few megawatt hours or as large as several gigawatt hours. The capacity is usually designed to support the required energy needed for operational purposes over a period of several hours. In many cases, these batteries are used in conjunction with other power sources and can be used for short periods. They can be used when other sources are taken offline for servicing or for an unforeseen interruption.
Batteries are used in an increasing number of devices to support our current lifestyle and working remotely and engaging in off-grid activities. All you need to do is look at the millions of smartphones and tablets that are used by hundreds of millions of people across the globe. Most of these devices were not available 25 years ago. The creation of these portable devices has driven the invention of smaller and more energy-dense batteries. Looking ahead, batteries will continue to be developed to support the increase in capacity and operational hours that society demands of its off-grid devices. Through this transition, many of the traditional sizes of batteries will decline in usage. Hopefully, this will also give us an opportunity to move towards standardization and eliminate some of the sizes of small batteries, maybe even C, D, and 6-volt batteries. An increase in standardization will help reduce overall production costs, reduce the likelihood of purchasing and having to return the wrong size of battery, and reduce the number of types of batteries that the typical household needs. It'll be interesting to see what the next decade holds for new battery types that store more energy safely and allow our devices to operate for longer periods without recharging. Better batteries will also be crucial for the adoption of electric vehicles by increasing drivable distances and reducing the overall cost of a vehicle.